Hi everyone, it's Nono here, and this is a working session part of the collaborative AI sketching project on how to build a drawing app. Multiple people and multiple bots and machine intelligences can draw together, can sketch together, and we can get intelligent suggestions from one another. And also developers or people who want to extend the system will have a protocol to extend it, or maybe expose other intelligent bots and machine learning models. This is a big intent. It's hard, but we're going to try it. We're going to take a look at different frameworks, and we're going to actually get hands-on coding to try to create our own drawing application and be able to draw in an endless canvas and have features in which we can draw in a web tab and have also the vector coordinates and data about the strokes that we're doing. Without further ado, let's get coding. There is this project called Perfect Freehand that uses y.js, and there is another one here that says Awesome Drawing App. We're going to take a look first at Awesome Drawing App. This is Awesome Drawing App, so this is in REPL it. I like the name. REPL is the REPL term, and then it for the brand. So we can see here the code of this application. Okay, yeah, so it works here. So we just get a canvas. So using Perfect Freehand and y.js and WebRTC provider. This is a project that is using Perfect Freehand and y.js and this WebRTC library. y-webRTC. Let's look. WebRTC connector for y.js. Propagates document updates peer-to-peer to all users using WebRTC, fast message, blah, blah, blah. What is WebRTC? WebRTC. With WebRTC, say real-time communication for the web. Add real-time communication. Okay, so really quickly, what is WebRTC? It's a real-time communication for the web. With WebRTC, you can add real-time communication capabilities to your application that works on top of an open standard. It supports video, voice, and generic data to be sent between peers, allowing developers to build powerful voice and video communication solutions. How does this compare? Okay, so this is a solution from Google. I want to see a comparison between WebRTC and WebSockets. Both are part of the HTML5 specification. WebSockets are meant to enable bidirectional communication between a browser and a web server, and WebRTC is meant to offer real-time communication between browsers, predominantly voice and communications. Two-way communication TCP, whereas PT enables peer-to-peer communication in the browser and mobile. WebRTC is more secure, only supported right now by certain browsers. WebSockets is compatible with almost all existing browsers. In terms of scalability, WebSockets uses a server per session approach and WebRTC is peer-to-peer. All right, so that might be the biggest difference, right? RTC is peer-to-peer, so it's browser to browser. On WebSockets, I would say, WebSockets, something like we have a server. I imagine this is your server. I don't know how to make this look like a server. And then you have different people that are connecting to it, right? So they're sending data and they're getting it. And we can say that we can connect a bot here, which has some sort of neural network in it. And it can also send. So this is a computer that is sending and receiving information. So you can send things maybe from an application, from your browser, and then a system can send from the command line. So let's say CLI, browser. And on the other side is WebRTC, which seems to be like different people with their devices, probably more like this, can communicate among them. We can probably also do other systems. So it would be different people. I think this is the difference in paradigm, right? From this would be this bot. Okay, so that's WebRTC versus WebSocket. And this one is made by Google, it seems. It's said to be more secure, but less supported for now. So this gives us a tiny overview on what that is. And it seems that example of code that we're seeing on the example that we have here, the awesome drawing app, is using that one. So I'm not sure if I open this here and I open two different ones, if this is going to connect the two applications together. All right, it actually does connect the applications together and it's super fast. So we have this concept of the circle, right? So it's always syncing. Let's take a look at the code. So y.js, so CDR, conflict-free replicated data types for collaborative editing are an alternative approach to operational transformation. A very simple differentiation between two approaches is that OT attempts to transform index positions to ensure convergence, while CRDTs use mathematical models that usually do not involve index transformation, like linked lists. OT is currently the de facto standard for shared editing on text. OT approaches here are better for the distributed system, provide initial guarantees, is a network agnostic, peer-to-peer, supports many existing rich editors, offline editing, version snapshots, undo, redo, and shared cursors. It scales well with an unlimited number of users and is well suited for even large documents. Demos. Okay, so let's take a look at the demos. Draw perfect pressure sensitive freehand lines. What's really nice is that with these example applications of the awesome drawing app that Rob shared, we actually get a lot done of what we intend to do on the live stream, right? With the collaborative AI sketching project, because it's using a protocol that allows for distributed drawing, so collaborative drawing, multiple people. We don't have a centralized database in this example, so everything gets lost. That's something we can work around to store the things that are being done. And we get vector drawing. So this is really nice. Let's take a look at, these bindings I've seen before. So these are examples on how to do collaborative writing. I could put two of these browsers here and we could say this is the Nonodogma live stream. This works pretty well. So cursor selection. This is view. So I guess we can take a look at how this is built really quickly so we get a bit more familiar. The WebSocket provider implements a classical client-server model. Clients connect to a single endpoint over WebSocket. The server distributes awareness, information, and document updates among clients. The WebSocket provider is a solid choice if you want a central source that handles authentication, authorization. WebSockets also send header information and cookies. Like in this video helps support the work that I'm doing here and also encourages me to do more of this. And if you subscribe, you'll get notifications when I go live next or when I upload new videos. But you already know this. The community, if you haven't introduced yourself yet, you can join Nonodogma Discord. There's a ton of people already, and I'm so happy that you guys are even connecting to see me online here. So it's super humbling. And yeah, thanks a lot for your time and for watching, and I'll see you next week.